How would I represent x is greater than or equal to 4 on this number line? What sort of circle do I use around the 4? A filled in circle. Why is it filled in? Because there's an equal to. 4 counts. 4 is part of the answer. Now what do I do? Draw a line to the right, which means the solution set for this inequality is anything that falls in that arrow. So 4 works, 5 works, 8.2 works, 1,000,000 works. Everything that's from 4 over will satisfy the equation. Okay, what if I had 3 is greater than, no, let's do negative 3 is greater than x. I need to put my negative 3. What sort of circle do I use? An open circle. Why is this one an open circle? 3 doesn't count. Negative 3 doesn't count. So this one's written backwards, but if we look at it in terms of x's, we see that x is smaller than negative 3. So which way should I write my arrow? To the left. And a lot of people will say, just point your arrow in the same direction that the inequality faces. So you see how that inequality sort of points to the right, and this points to the right? Well, that's not always true. That's only true if your variable is on the left. So in the next one, the arrow is going to the right, but we drew our solution to the left. So you can't necessarily trust the direction. You have to look at the variable and then figure out the direction. So x is smaller than negative 3. So negative 2 doesn't work. Negative 2 is not smaller than negative 3. Negative 2.5 doesn't work. What about 3? Negative 3. Negative 3 doesn't work. But negative 3.1 will work. It has to be smaller than negative 3. Okay? What if I had 2x minus 4 is equal to negative 6? Oh, not equal. I want greater than or equal. What should I do? I'm going to solve this just like it was an equation and then simplify it down to its solution. Add 4. 2x is greater than or equal to negative 2. Now what? Divide by 2, and I get x is greater than or equal to negative 1. The solution for that would be negative 1. What kind of circle? Open circle. Should I shade to the right or to the left? Well, look at the variable. X is bigger than negative 1. Bigger means to the right. This is all review, correct? You all know how to do this? Okay. What about this one? 8 minus 4x is less than or equal to, actually let's do greater than, is greater than or equal to positive 12. Oh, that's not what I want to do. Let's say 20. What should I do first? Subtract the 8. Oops, subtract the 8, not divide. And they end up with negative 4x is greater than or equal to 12. Now what? Divide by negative 4. Ah, good. You remember. Whenever you multiply or divide by a negative, you have to flip the inequality. And I don't think anyone's ever told you why that's the case, but I will. So the answer should be x, and I flip that, is less than or equal to 12 divided by negative 4 is negative 3. Okay. Why do you have to flip the inequality when you multiply or divide by negative? There are two explanations. For the first one, well, I'm going to solve this in a little bit of a different way. What if I move this over and I move that back? Watch what happens. I'm going to add 4x to this side and subtract 20 and subtract 20. Negative 12 is greater than or equal to 4x. And if I divide by 4, then I get negative 3 is greater than or equal to x. Is that the same thing that I got on the other side? Do you see how this and this are the same? Yes? Well, if I hadn't flipped the inequality from here to here, would they match? No. So that's one explanation, but it's not the one that I like. Here's the explanation that I do like. Let's say I had 3 minus 2x is greater than, what should we do, 5? Okay, let's consider this as a balance. If it said 3 minus 2x equals 5, then we could create a picture where we had 3 pounds. So those are 1 pound rocks. And, well, actually, let's make it, let's do this. 2x plus 3 equals 5. So this is balanced. We have 2 x's, and we don't know how much the x's weigh. And then 3 1-pound rocks. And then over here we have 5 1-pound rocks. Can we use this balance to figure out how much each x weighs? Well, I can do anything I want to an equation as long as I do it to both sides. So let's eliminate 1 rock. Is it still balanced? Yes. So I eliminate another rock. Is it still balanced? Yep. I eliminate another rock. Is it still balanced? I'm taking the same weights off of both sides. And now I'm left with 2 x's and 2 rocks, so each x must weigh equal to 1 rock. Okay? Let's try one that's a little more complicated. Let's say 15. So I have a balance here. So I have 4 x's and 1, 2, 3, 4, 5 rocks. 1, 2, 3, 4, 5. What would I do to this to figure out how much each x weighs? Oh, I didn't mean 15. I meant 20. Sorry. There we go. So I need to get rid of 5 rocks. So I go over here and I eliminate 5 rocks. It's still balanced. I have 4 x's is equal to 15 rocks. Oh, that doesn't come out very well. Wow. I really didn't bring my A game today. How about this? Now I have 4 x's and 16 rocks, so each x must weigh 4 rocks. Okay? Makes you wonder how I ever graduated from college. 3 times. Yeah, that's weird. Okay, what about negatives? 2x minus 1 is equal to 3. So what we have here are two x's, and those x's are pushing down, right? And then on the other side, we have 3 rocks, and those rocks are pushing down. How would I do a -1? It would be a balloon that is pushing up with the weight of 1 rock. Does that make sense? So if I have 2 x's on one side and then 3 rocks on the other, plus, well, I guess subtracted by a balloon on the left side that's pushing up, and I have a balance. Is there any way to remove this balloon and keep everything balanced? What would I need to do? If I push up with the force of 1 rock on one side, what's the equivalent motion on the other side? Push down. So if I remove this balloon and put a rock over here, it's still balanced. Does that make sense? Or you could add a rock here and add a rock here, and those two will cancel. Okay, and now I have 2 x's and 4 rocks, so each x must be 2 rocks. Okay, now why do we have to flip the inequality when we do divide by a negative? So if I had x plus 4 is greater than 5, what that means is I have an x on one side and 4 rocks, and I have 5 rocks on the other side, but this is not balanced, correct? What is happening with my inequality? What do I know about the left side? It weighs more than the right side, right? So it doesn't actually look like that. It looks like this. So how much does x weigh? Well, let's figure it out. Let's subtract 4 and subtract 4, and I get x is greater than 1. Or in the picture, I get rid of 4 and I get rid of 4. So how much does x weigh? More than 1. Could it be 2? Could it be 8? Could it be 1.1? Yes, as long as x weighs more than 1 rock, that unbalanced stays. Right? And how many answers are there? There are an infinite number of answers, which is why we use a number line. We circle this, and we shade to the right. That's a 1. Let's look at it if I had negative 2x is smaller than 8. Okay, which side of the balance weighs more? The 8, the right side. So it's going to look like this. I have 8 rocks over here. And I have, what would negative 2x's look like? They'd be balloons. So I have 2 balloons that are both x's, and they're pulling up. Okay. What happens when I divide by a negative? Or times by negative? Let's times everything by -1. What is negative 2x times -1? 2x. And what is 8 times -1? -8. And we look at this. What have I done to my picture? Well, I have turned my x balloons into positive numbers, which means they push down. And my 8 rocks have now become 8 balloons. Does that change the picture? Yeah, it totally flips it the other way. Now I have 8 balloons that are pushing up, and two x's that are pushing down. But that didn't happen when I had equality. Right? If I had two x's and four rocks, if I turn the x's into balloons and the rocks into balloons, am I still balanced? If I'm pushing down with the same force and I'm balanced, and I push up with the same force, do I stay balanced? So what I'm saying is, if we had an x here and two rocks, and I turn them both into balloons, so an x balloon, and those two balloons, are they both balanced? Yes. So with an equality, you don't have to worry about multiplying and dividing by negatives. But when you have inequalities, something like this, and you multiply or divide by a negative, you end up flipping the scale to the other side. And because you do that, you need to switch this to the other way. So it would look like that. So the rule is, if you multiply or divide by a negative, the inequality needs to flip. Okay? Well, what if I had something like this? Y is greater than x squared minus 1. Well, if I graph x squared minus 1, it's a parabola. So I'm going to go into y equals, and I graph x squared minus 1. So it hits the y-axis at -1, and it looks like this. Is this an open circle or a closed circle? Open circle. Well, whenever you graph an open circle, you actually use a dotted line. Okay, where are the answers? Well, look at the y. Y is bigger than x squared minus 1. So are the answers going to be above the graph or below the graph? Above, because y, the y-axis, the y values, are bigger than the equation. So the answers are actually everything in here. So let's try one. Let's try the point 1, 3. 1, 3. That's an x and that's a y. If I put 3 in for y and 1 in for x, is that true? Is 3 equal to 1 square, or sorry, not equal. Is 3 greater than 1 squared minus 1? Yeah. Let's try the point 1, -1 right here. 1, -1. I put -1 in there. Is -1 bigger than 1 squared minus 1? So 1 squared is 1, 1 minus 1 is 0. Is -1 bigger than 0? Would you rather have -$1 or $0? You'd rather have $0. Right? You'd rather not be in the negatives. So this point was a yes, and this point was a no. So any point inside this shaded area is part of the solution. Okay. What if I had y is less than or equal to x squared plus 2x minus 1? Well, I need to plug that into my calculator. X squared plus 2x minus 1. Oh, that's not going to work. Graph it. I draw the graph. Is this going to be a solid line or a dotted line? How do we know? Equal to is solid, not equal to is dotted. So we end up with this. And am I going to shade above or shade below? Well, look at the y. Y is smaller than the equation. So the answer would be all of this stuff. that make sense? Okay. All right. Sometimes you'll have two equations. So y is greater than x squared minus 4, and y is less than or equal to negative 2x squared, what should we do? Plus 2x squared plus 4x plus 8. So I need to plug these in separately. X squared minus 4 and negative 2x squared plus 4x plus 8, and then graph them. So here's the first graph, and there's the second. Is the first graph solid or dotted? Should I have a solid line or a dotted line for that equation? Dotted, okay. So it's the blue one, dotted like that. And then for the next one, I need a solid line. And then I have to see where to shade. Where do I shade this one? It's going to be above the dotted line, which is the inside of the parabola. So it's sort of this stuff right here. But I don't want to shade that yet. But I know that it's everything in the middle, inside that. Okay? And then for the next one, where do I shade? Everything smaller than the graph, which would be all of this stuff. But I don't want to shade that yet. Is there a place that satisfies both of them? We have this little area inside here that is above the dotted line and below the solid line. Okay. What if I changed this to a greater than or equal? Then we need to go above the dotted line, which is there, and we need to go above the solid line, which would be there. So it would just be this stuff. You guys see that? Okay. What if this one was changed to a less than? Where would I shade? We need to be underneath both of them, which would be this area right here. Okay? All right. I want you to do 4, 9, 3 through 14. Okay, I'll write it out. So 4.9, 3 through 14 all, 17, 18, and then 21 to 26 all. All right, good luck.